Okay, so continuing what we started Friday, talking about improper integrals. This time last time we addressed as we trend toward the infinite. Okay, so let's change that. This is what we looked at Friday. Something like the integral from 2 to infinity of 1 over x. And does that converge or diverge? Remember those words? Converge gives us an answer, diverge goes to infinity, right? Okay, so that was Friday, wherein we would solve this as a limit, right? If we're going to find something very similar today, we're going to look at problems with infinite discontinuities at one endpoint, right? So if I give you the function 1 over x, right? Where is that discontinuous? At 0, right? So the domain is negative infinity to infinity, x cannot equal 0, right? So something you might see would be this. Calculate the answer to that. Is there an area under that curve between the curve and the x-axis? Noticing that our infinite discontinuity is right there. Correct. And if you remember, there's the graph. So basically we're trying to calculate that area.
So,
right?
Why do you call it infinite discontinuity?
Well, because it's an infinite discontinuity because the function goes to infinity at that point. So as x approaches 0 from the right or the left, from the right we go to infinity, or the left we go to negative infinity. Right? Versus a jump discontinuity, right, which is a jump, versus a point discontinuity, which is a hole. Okay, good. The way we deal with this is very similar to what we did Friday. We're going to make this a limit, right? So it would be the limit as r approaches 0 from the right side. Okay. Because we have to come from the right side of 0. Okay, then we can just execute. Antiderivative of 1 over x. Right. Hearing a lot of mumbles. Yeah, we don't have to have that on there, but it's good practice probably to. That's the old AP free response. Ding, -1, because you are not being prudent, I guess. All right. What does that approach? Natural log as we approach 0 from the right. No. You remember what the graph of natural log looks like? So as we approach 0 from the right, where's this going? Negative infinity, right? So this actually is infinity, correct, this answer?
Yeah.
So this problem actually diverges. Okay.
So, question, is 1 over x and natural log of x like opposite graphs?
They are not inverses.
No, e to the x natural log.
Yeah.
So,
So natural log x and e to the x are inverses. So notice that this point is 1, 0. This is 0, 1. See, the x's and y's are switched, right? And then as we go to infinity, it approaches 0. As you go to 0, it approaches negative infinity. You reflect it across this line, y equals x. 1 over x has an inverse of itself, believe it or not. Yeah, it's a reflection over this line. So any point, they just flip over and it mirrors itself. Okay, so that diverges, right? And what you'll notice, if you continue to calculate these out, if p is greater, if I have this integral, there's an infinite discontinuity at 0, right? Anything with p greater than or equal to 1 is going to diverge. Yeah, so I'm only saying greater than or equal to 1. So if you know that if it's x to the first, x to the second, x to the third, any of those, this diverges. And it's a theorem. So you can actually state that based on the theorem.
So if we see like too much 1 over x and that stuff, and it just says diverges or converges, can we just say diverges instead of theorem? If it asks for like justification.
If it says justify your answer, that's a tough one to call on the AP end. On a multiple choice, obviously, not to justify. You'd be tempted to say diverges because of theorem 2 in our book, but I don't know if they'd accept that answer, to be honest with you. I'll look it up, though.
All right.
How about that? Yeah, I'll take a look and see what. I'll see if there are any free responses of this nature, which I doubt, but I'll take a
There
look.
is one, probably,
Okay. All right. Let's take a look at one very similar. What's the p-value? Yeah, it's 1/2 in this case. What do you think's going to happen?
well, since you have the square root of 2, it's irrational.
It's going to converge. Right. So, but let's work it through. That would be x to the 1/2, right? Is that correct? And you're going to see we
divided by 1/2, you get 2.
What'd you say?
How did you get 2? Divided by 1/2?
Yeah. Yeah. So if we calculate the limit, this is as r goes to 0, right? So that's 0. And we get 2 times 2 to the 1/2. So 2 root 2. So that converges.
I don't think we really did the limit for that.
We're going to have it.
want to be correct in your notation, you need it. But to get the answer, no, you really don't. So, if P is less than 1, guess what? This converges. Okay, so that last one, P was greater than or equal to 1. We know these diverge. Here, we know they converge if they're less than 1, strictly. Okay. And this includes like -2. If P is -2, we're really just integrating x squared, right? Yeah, you're still going to get an answer. So it includes the negatives and 0.
So if you do 0 to 0 power is 1. Yes.
0 to 0 is an indeterminate form. Yeah. So that's when we get into possibly using some messy methods for calculating those. Okay. So there's a couple of those. You can also, let's look at this one here, and then we'll be good.
So this is like the same thing as the
Yeah, basically. You just have a different function here. So where is the discontinuity here?
1.
Yeah. So we are going to have to do our limit as our approach is 0 or 1, correct? From the left side. Because 1 is up here, so we have to approach it from the left. Right. So just be wise about which point is discontinuous, and choose your.
from top, the other approach from the left.
Yeah. 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 Thinking graphically, this is the right-handed limit, this is the left limit, or sorry, left limit and the right limit for the integral, but we have to approach it from the left. You remember that integral?
And sine inverse.
So we have the limit sine inverse r minus sine inverse 0. Do you remember how to solve inverse sine?
It's pi over 2, isn't it?
Yeah, how do you know that's pi over 2?
It's just opposite of what we think.
Basically.
And just
Where is sine have a value of 1?
power 2.
Yep. Okay, so again, sine has a value of 1 at pi over 2. That's what this is asking. Sine inverse at 1 is the angle. So, and then sine at 0, 0, so we have our answer. Okay.
So the limit is still just pi over 2 because it's approaching.
Yeah, see, this is actually continuous at 1, or, right? This actually has a value, whereas that does not. So our exercise with the limit really doesn't have much of a bearing on this problem, except for formalities. Yeah. Okay. Any questions on those? Very similar to Friday. Alrighty then. That's it. Do you need to write the homework down again? Okay.
Yeah, I wrote that down. I'll just wait till tomorrow.
This was America. This is
Yeah, the context. Yeah, I did them online though, so in one class. I'm a little bit.
One through 11 odd.
Yeah, I'm sorry. It was easy to type in my voice.
Well, I mean, we still have homework.
They take like half the time.
There was a lot of it.
Once you start.
I mean, like,
Did you do the cartoon?
yeah, I mean, unless you're not.
Yeah, that's specific.
Oh, yeah. Apparently, I read that in the last.
Oh, I see. 'Cause I-
There you go.
Okay,
I'm guessing that's the third thing.
No, tomorrow.
So we got two assignments due now.
No.
Nope. So
No,
what was?
because this is
That's the
our
same
last
one you got last
Oh, that's the
Friday.
same one.
It's the same as Friday. Yep.
Cool.
Yeah, it is.
Is that the same exact?